Hi. Yesterday, I spoke with a fellow named William. William's from San Francisco. And he called because he lives in a 6-unit building which has a NuTone 478 apartment house intercom entry system. William's building has a variety of problems. Of course, he's unsure exactly how old the system is. Best guess, it was probably installed somewhere in the mid to late 80s, but he's not sure about that at all. The breakdown of the problems are all 6 units, the call tone works, and probably 3 out of the 6 have communication with the entrance. But recently, like in the last month or two, the door release to let people into the building has failed and stopped working. One of the things that you have to take into consideration when you're trying to diagnose a problem with an apartment house entry intercom system is you need to sort of have a survey of what's going on in your building. I speak with a lot of people who will tell me, oh, I have no communication, and it's like, well, ma'am, how many people live in your building? Well, there's 42 units. Well, out of the 42 units, are there other ones that don't work? Usually the answer is something along the lines of, no, I think they all work. Well, have you actually talked to people about it? No, not really, but I think they do. And you have to look at the overall system as where the problems may be, not just your individual unit, because it could be a problem with your unit, it could be a problem with a group of units in the area of your building, or it could be a system-wide equipment problem. It's hard to say. The thing that made William call me yesterday was the last straw was the door release stopped working. And of course, when the pizza delivery guy shows up and you can't buzz him in the building to get your pizza while it's still hot, that's going to be a problem. So I thought I would make a brief video about the easy way to try to figure out where the problem lies, because there are 3 likely problems that could cause the door release not to work. As I tell a lot of people when I speak with them on the phone, there isn't always just one problem. Sometimes there can be more than one problem that are associated with the situation you have, so you have to look at the whole system as a whole. So where are the 3 most likely problems? It could be a problem with the door release switch on the N45 speaker, that's this one right here, but the odds that 6 of these switches all went bad in the same building at the same time, very rare. Honestly, in the almost 40 years that I've been doing this, I have never had an occasion to replace one of these switches. They just, unless it's like physically like somebody attacked it with a hammer and broke it. Other than that, no. They're just a very simple spring-loaded slide switch. There really isn't much to go wrong. A little cleaning, and I will put a video, because everybody I talk to about apartment house intercom stuff, cleaning switches in apartment stations is a key thing to do, and I'll put one of those little pop-up videos or links right up here, and you can go watch that video how to do that. So odds it's a switch, not very likely. Also, odds that it's a wiring problem throughout the building. Didn't sound like it to me. There's a game I've always played. The game is called What Are the Odds? What are the odds that in a building with 6 units, some wiring problem developed suddenly and it disabled a function for the entire building all at the same time? Not very likely. You always have to look at what the odds are of something like that having happened. While it could be a switch problem, I doubt it. More likely, it could be a problem with the 478 control amplifier, or it could be a problem with the door release itself, or it could be a problem with the wire that connects the door release to the 478. One of the questions I always ask people when they call about door release problems is it on for instance, a wooden entry door that's part of the building, or is it an ironwork gate that's in front of the building or on the sidewalk? Because those can create different situations. Ironwork gates are out in the weather, and that causes things like door releases to fail. The other problem with ironwork gates in a lot of installations are iron gates are heavy. And ideally, they should have some kind of hydraulic door closer on them that controls the closing of the door. It closes rather rapidly, and then the last 3 or 4 inches it slows down, and then it very carefully latches closed. That's ideal. A lot of buildings that I've been to don't have a hydraulic door closer, or it has been removed at some point, and when people come and go, they open the gate to walk out, and then they wham, slam it closed, and it basically beats the door strike to death. You know, a standard passenger size like a 36 or a 40-inch iron gate, that could weigh several hundred pounds, and if it's getting slammed 8 or 10 or 12 times a day, it's going to take a toll on the door release. Wiring problems are wiring problems. There's a pair of wires here. You can see it here. It has a red and a white wire. Inside it's 18 gauge wire because it's powering an electromagnet in the door release. These 2 wires run back to the terminals on the control amplifier. Wiring problems do occur. We had a building that we took care of for decades, and suddenly one day something went wrong. I don't know exactly why it happened, but there was a short in the wire right here near where the door release was mounted in the aluminum storefront frame, and it shorted across the aluminum, and it created a situation where the door release wouldn't work. We repaired the short, put some tape and insulating over it to protect it, and then it all worked great. So it could be something as simple as a wire. Sometimes mouses chew on wires, or things break loose or whatever, so you know, you have to look at the wire. And then lastly, and actually most commonly, or maybe most commonly, it's probably a push either way, whether a door strike or the control amplifier would be the primary thing to look at first. But these control amplifiers can fail in regards to activating the door release. There's a reason why this is called a control amplifier. And here you can see 478 control amplifier. It's not just an amplifier for communication. It also controls different aspects of the system. It includes the circuitry to cause the call tone to work. And this would be the button on your entrance directory. It coordinates the talking and listening from the apartment station, talk. I have it connected to a speaker over there on the end of the workbench, and then listen. So it controls that. It also controls the door release. And the way this works is when you slide the switch to door number 1, you hear the door strike rattle. We'll talk about rattling door strikes at the end. In this type of installation where it's a simple installation and there's only one entrance, the door release switch works either for door 1 or door 2. It doesn't matter, the system doesn't care. When you move the switch, you're turning on some circuitry in here, and that circuitry turns on an electronic switch that's on the circuit board in the control amplifier, and when that switch closes, it allows power to flow through to the door release terminals here, which then travel down the wire to the door release, and then it's energized. So there are 3 things to check. We have to check the control amplifier, we have to check the wire to the door release, and we have to check the door release itself. We're going to start at this end, at the amplifier end, because that's the easiest thing to do first. So what you're going to do is, we're going to disconnect 2 wires here, and we're going to measure for voltage on these 2 screws when someone moves the door release switch. In this close-up view of the terminal board on the 478 control amplifier, you can see these are the 2 screws we care about, and it's labeled on the board above the screws as main door release. And we have the 2 wires, one's red, one's white. To measure voltage on these, you need to disconnect one of the 2 wires. You can disconnect both if you really want to, but you don't really have to. You only have to do one. Once you remove the wire, the other thing that's important is you have to tighten the screw back down. Now don't over tighten it, because the screw threads into the fiberglass circuit board, and if you over tighten it, you will strip it out, and that creates a problem for trying to get the wire to stay securely under the screw later on. So just snug it down. The reason you have to tighten the screw back down is because the flathead screws rest up against these round copper pads that's part of the circuit board, and that's what's connected to these terminals up here that go into the control amplifier. So if you don't tighten it down, you won't get a valid reading. Once you've done that, then you need a multimeter of some kind. And today, we're going to use our handy dandy Fluke model 83. This Fluke 83 I've had forever. This Fluke 83 has been responsible for troubleshooting probably hundreds of apartment house entry intercom systems, so it's well experienced. We're going to set it to AC volts, and you can read the readout here on the display. Now what we're going to do is we're going to measure the voltage across the main door release screw terminals with our meter. So black probe goes on the left, red probe goes on the right. It does not matter which way you put it around. And if you measure it, you can see on the meter it shows 11.5 volts. And you might be going, well, that's crazy. How can there be 11.5 volts? There's obviously something wrong with the control amplifier because it's putting out voltage all the time. So wouldn't the door release be turned on all the time? The answer to that is no. It's an idiosyncrasy of the design of the 478 amplifier. There is always a little bit of voltage that trickles through to the main door release terminals, but there is no current behind the voltage. Current is the power. Current is the force behind the voltage. It's a little hard to explain for people that don't understand it. What happens is as soon as you hook a device to it, for instance, if we take our door release wire, the white one, and we touch it to the screw, you'll see that the voltage drops down to almost nothing. It's 0.4 volts. What happens is the resistance of the coil in the electromagnet of the door release drags the current down, uses up all the current that's available, and then the voltage drops to almost nothing. So while we have the probes on the screws, oops, it slipped off, and we have our, see, how good of a voltage reading you get depends a lot on how you hold the probes down. Then you have your helper that's upstairs in one of the apartments. Move the door release switch to door number 1, and the voltage jumps up to 12 volts, give or take. And that would be fine. So that indicates that the circuitry in the 478 control amplifier is fine. If you still get virtually 0 volts, then there's a problem with your 478 and it needs to be repaired. Now what we're going to do is we're going to reattach the white wire to the terminal for the main door release, so it's back like it was. And then you're going to go down to the lobby where the entry door is, and you're going to take the door release out of the door frame. Now, door releases are complicated because there are literally 1 zillion different kinds. This door release happens to be a real genuine NuTone door release. It's a model DR1BA. BA is for brass. It's an electric door opener, 16 to 24 volts AC. This is the one I use with testing when I repair people's 478 amplifiers because it's a genuine NuTone door release. What you have in your door frame may be different. There's lots and lots and lots of companies that make door releases, but this is just an example. So once you get this out of the frame, you'll find that it has whatever door release you have. It'll have a couple little wires that come out of the door release, and they'll be attached to the 2 wires that come from your 478 control amplifier. Now what we're going to do is pretty much repeat what we did before. We're going to take our probes, and first I'd like to measure the voltage before we disconnect it. And again, sort of like what we had on our 478 control amplifier, we have 0.3 millivolt. It's almost nothing. Once you've done that, now what we're going to do is we're going to disconnect or unsplice one of the 2 wires that connect from the 478 to the wires on the door release. This particular installation happens to have these little crimp connectors, and if I squeeze it carefully, I can open it up and disconnect the 2 wires. You don't have to disconnect both of them, just one side is fine. Your installation may have little blue wire nuts. That's all right too. Once we've done that, if we measure this again, and this is hard to do in the video, we got 6 volts again. Why? I already explained why. Same as when we got higher voltage when we measured on the terminals of the 478. So if I can hold these properly, which is not easy to do, because somebody's got to move the switch. Alright, new configuration. I've got the probe jammed in one of the beam connectors here, so I only have to hold one of them. And now we have our 6 volts, which is close to 6, like we had on our 478. Now you have your helper move the switch on the apartment station, and we have our 12 volts. So what does this prove? This proves that the wire between the 478 control amplifier and the door release is good. There's no shorts because the voltage is present when the switch is moved on an apartment station. So what does that leave? That leaves most likely the problem being the door release. Now if you measure here and you don't get your 6 volts, we'll call it standby voltage because that's an easy way to think about it. It's the voltage that's available when the system is not being used, the door release switch is not being moved, so it's kind of in standby. So your standby voltage is 5 1/4 right now. If you measure here and your voltage is essentially 0, then you probably have a shorted wire, and then you have to check the continuity on the wire and see if that's the case, and then figure out what to do about it. And then when you move the switch, again, there's our 12 volts. So we know that the 478 is supplying 12 volts to the door release when someone moves the switch, which is what you want. Likely, it's a door release that's the problem. A door release is a fairly simple electromechanical device. Essentially what you have inside here is, open this up. In this particular one, we have 2 electromagnetic coils with plungers and springs. When it's energized, it pulls this plate down. And as it pulls it down, when it's in the upper position, it locks the latch, so you can't force it open. When it pulls it down, it moves these arms out of the way and allows the latch to flip open. It's hard to do with one hand, like that. That's all that it is. Odds are, if your voltage is getting to the door release, you have a problem with the door release itself. I don't ever really recommend you try to repair the door release. It's easier to just buy a new one and put it in. My advice to you on that is it's a hard thing to buy online. The best thing to do is go to a local locksmith that has door releases available to him. Take the actual door release with you if you can. Now sometimes you get lucky and there'll be a sticker on it like this one, and it'll tell what brand it is and what model it is, and if you have that, you can always call the guy first and see if he can order one of those, or maybe you find it online because you know exactly what it is. The differences in door releases a lot of times are physical differences. It's the size of the plate that mounts in the door frame. It's the spacing between the screws. Some have 2 screws, some will have 4 screws. It's the depth of the mechanism itself. It's the way it's constructed inside. And door releases can range in cost from your cheap low-end door releases, which maybe in today's world, it's been a long time since I bought one, maybe I don't know, 40, 50 bucks, pretty cheap. There are actually door releases made by companies that cost thousands of dollars. It all depends on how physically well made that it is. A $50 door release, if a guy really wants to get in, he's going to get in. It's not that sturdy, it's not that strong. You can force the door, bend the parts inside, and get it to unlatch. If you buy a $1,000 or a $2,000 door release, you're going to need some kind of armored vehicle to knock the wall down to get into the building. So whatever you have though, that's what you would replace it with, something exactly the same, because nobody wants to change the door frame configuration, especially if it's wood. Alright, our 478 system has been reassembled. We've solved our door release problem because either it was an amplifier that needed to be rebuilt, it was a shorted wire, or it was a bad door release, or some part of all 3 of those, because it's not always one thing. Remember, it could be 2 things. You could have a bad door release because the gates pounded it to death, and because that's failed, it's taken out the components in the 478. So let's go ahead and verify that this works. We'll buzz as the pizza delivery guy. We can talk. We can listen, and we can release the door. Now, let's listen to that one more time, up close and personal. That's the sound that almost everybody expects to hear when being, quote, buzzed into a building. It's the rattly sound of the mechanism inside the door release. That is technically wrong. If you look here on our 478 control amplifier, there are actually 2 sets of terminals for door releases. This is main door release up here, and this one at the top above it says, just to be accurate, second door release. Right here. Because some buildings will have more than one entry. So you can choose which door you want to release instead of releasing both of them. You'll notice on this set of screws here, there's this little doodad going across right here. That little doodad is that. What is that? That's a diode. They come on here because even though the door release, the NuTone genuine door release, has 16 to 24 volts AC, when you take the diode off, which is how you find most installations, easily I'm going to say 99.5% of all installations, the diode has been removed or it's been snipped off and left hanging there. Purpose of the diode is to prevent it from sounding like this. So I'm going to stop and I'm going to put the diode back on and you can hear what it's supposed to sound like. Our diode has been reinstalled. Now, one thing to know, diodes have polarity. They have a plus and they have a minus. And on the circuit board right here, it's silk screened with the little symbol of a diode, and it's a little triangle on its side with a little bar in front of it, and the bar represents the stripe on the diode, and all diodes have a stripe. When you reinstall this, you have to reinstall it in the correct direction, otherwise it won't do what it's supposed to do. So now we have it hooked back up, so let's listen to what it's supposed to sound like when you have the diode. Listen carefully. Now, it went click, and there was a little bit of a buzz. Not as much as a rattle as before, just a little bit, but you have to take into account that this is being held up right to the microphone like this. If this is in a door frame, and it's all screwed in and everything, and the visitor who's pushing the button at the directory is 4 feet over that way, or 2 feet, or whatever it is, when it goes click, they're not going to hear that, because it's concealed in the door frame and they're far enough away. All they're going to hear is the click. This is the way it's supposed to be done. It's vibrating around on the desk some. See if we can do it this way. There we go. That's better. All right. That's the way it's supposed to be done. It's not what property owners want. It's not what people who live in the building want. It's not what visitors want, most importantly. People are all very used to hearing the giant rattly sound to let them know the door has been released. And even though it's technically wrong, and even though it always drives me crazy, that's what people want. You got to give people what they want. They want the rattly sound. Otherwise, the complaint you will get from the property owner is people are complaining and they don't know the door is released and they're missing pulling the door open, and then the pizza's getting cold. You can't do that. Diode is correct. It's almost never used. If yours has one, great. If it doesn't, don't sweat it, but it is one of those little fine points that bothers me sometimes because I like the things to be done correctly. That's how you troubleshoot the lack of door release on a NuTone 478 control amplifier intercom system. I hope you found this interesting, and maybe for someone, including William, it will be helpful. If it is, give it a thumbs up on YouTube, because that will help us a whole bunch. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.